To appreciate the importance of careful disassembly, maintenance, and reassembly of the fuel injection system, it is important to fully understand the system's components and how the system operates. A separate fuel injection system is provided for each cylinder. Each consists of a fuel injection pump, the fuel oil conduit, and the fuel injection nozzle. The fuel injection pump is a close-tolerance plunger-type pump. Its major components include the tappet assembly, the plunger and barrel, the fuel entry port, the fuel rack, and the delivery check valve. The fuel injection pump connects at a fitting on the side of the cylinder head by means of steel conduit, which runs through a bore in the cylinder head to the fuel injection nozzle. The conduit provides the path for the fuel oil from the fuel injection pump to the fuel injection nozzle. The fuel injection nozzle consists of the body, the needle valve, and the nozzle tip. O-rings located on the injector body prevent potential cross-contamination between rocker arm lube oil and fuel oil. Cooling water supply and return tubes connect to the injector body above the cylinder head top surface and run to fittings in the side of the valve gear housing. Injector cooling water is directed through passages in the body and the tip to maintain correct nozzle tip temperature. The fuel injection pump meters the fuel according to load requirement and delivers it to the fuel injection nozzle at high pressure at the proper time for combustion. Let's take a close look at this process. The engine control system operates a governor that regulates the position of the fuel rack. The fuel rack is provided with a pointer and a calibrated position scale. As the fuel rack position is changed, the plunger is rotated within its barrel. This rotation controls the position of the plunger's helix surfaces, which determines the length of the effective stroke and meters the amount of fuel entering the pressure chamber. As the plunger moves downward during the return stroke, fuel flows into the high-pressure chamber. As the camshaft is turned, forcing the cam follower to push up on the tappet assembly, the plunger rises. The rising plunger closes the fuel entry ports and compresses the fuel in the high-pressure chamber. The fuel is then forced past the delivery check valve, through the conduit, and into the fuel injection nozzle. When the pressure of the fuel reaches 3,500 plus or minus 50 psig, it overcomes spring tension, raising the needle valve, and fuel sprays into the combustion chamber through 10 tiny holes, delivering a fine mist at a 70-degree angle to the center line of the cylinder. Back in the fuel injection pump, as the pressure drops in the high-pressure chamber, the fuel oil delivery check valve reseats, preventing fuel from returning to the chamber during the return stroke, and maintaining residual pressure in the fuel oil conduit and the fuel injection nozzle. This residual pressure is essential for proper timing. Any fuel that leaks from the conduit connections will return through the annulus, which is the opening in the cylinder head bore outside the conduit. This leaking fuel is then directed to the clean fuel gravity drain piping located by the fitting on the side of the cylinder head. Here, the drip rate of leaking fuel can be monitored through the sight glass attached to the gravity drain piping. A detailed discussion of the fuel injection system and related maintenance issues will be covered in other sections of this program. Before starting maintenance, make sure the system is tagged out and the fuel system is drained in accordance with shipboard procedures. Residual fuel within the lines may be present. Handle in accordance with shipboard procedures. Secure the engine room ventilation to prevent any foreign material from entering the engine. Draining the injection nozzle cooling system can be accomplished by either using low-pressure air to clear the lines back to the expansion tank, or, in the event the blowdown adapter is not installed, you can drain the system coolant from the low-point drain. You need to ensure that you only drain the system below the cylinder heads. You do not need to drain the whole system. Be sure that the cylinder cover and cap are marked with the cylinder number so that they will be reinstalled on the same cylinder. Remove the cover and cap assembly together as one piece by loosening the valve cover screws. This will allow access to the upper valve train assembly. When the cover and cap assembly is removed, the cover gasket will often stick to the cover and come off when the assembly is removed. If it does not, be sure to remove the cover gasket. Inspect the valve train assembly for broken or loose parts and any notable fuel or cooling water leakage. Remove the injection conduit clip. Using an Allen wrench and a soft-faced hammer, loosen the conduit flange cap screws. Now tap the sleeve toward the conduit flange in order to expose the hexagonal section of the fuel conduit. Next, you will need a 19mm open-end wrench and a 46mm open-end wrench. Hold the conduit steady using the 19mm open-end wrench while using the 46mm open-end wrench to loosen the nut holding the injection pump outlet connector. Remove the nut from the injection pump connector. Removal as well as installation of the 6 upper flange screws should be done in the cross-pattern order indicated here. Note the cross-pattern sequence. Loosen the pump's 6 upper flange screws. Again, make sure to do this in the proper order. Now, rotate the connector assembly in order to allow removal of the conduit. Install the foreign material exclusion cap, or FME, on the threaded end of the connector. Using a 19mm wrench on the hexagonal section of the conduit, loosen the conduit from the injection nozzle. Once loosened, remove the conduit. Be sure to protect the ends of the conduit with lint-free rags or plastic FME caps. To remove the injection nozzle, you must first loosen and remove the hold-down nuts. Install the injection nozzle puller on the rocker assembly and thread the puller rod into the injection nozzle body. Using a wrench, rotate the nut to extract the injection nozzle from the cylinder head. Using the puller, remove the injection nozzle for testing. Place the injection nozzle in the test stand. Inspect the nozzle to conduit gasket. If the gasket is damaged, the injection nozzle must be replaced. Inspect and clean the injection nozzle adapter port and the adapter. Now, attach the fuel line and tighten both end fittings. To pop test the injection nozzle, prime the test pump with quick strokes of the handle until fuel is ejected. Note, the pattern of the fuel should be equal through all holes, with no stringers or after-pop dripping. Pump with slow, even strokes to provide continuous, uniform popping while inspecting for proper spray pattern. If the spray pattern is not uniform or dripping occurs, repair or replace the injection nozzle. Observe the nozzle opening pressure on the test pump gauge. Note, the proper opening pressure is 3,500 plus or minus 50 psi. If the nozzle opening pressure is below 3,200 psi, it must be reset. We'll discuss this in a moment. Maintain a steady pressure of 2,900 psi. There should be no leakage at the nozzle tip. After testing the injection nozzle, if it passes pop testing and does not leak, then the nozzle can be reinstalled. If leakage occurs, as in this close-up view, the injection nozzle must be replaced. As mentioned earlier, if the nozzle opening pressure is below 3,200 psi, it should be reset to 3,500 psi plus or minus 50 psi. Reset the nozzle opening pressure as follows. After installing the injection nozzle in the nozzle holder, remove the cotter pin. With a hammer and screwdriver, bend the locking tab up. Remove the injection nozzle locking nut using a 32 mm wrench. Remove the lock washer. Back off the adjusting screw 2 full rotations. Install a new lock washer, making sure its alignment tab is inserted into the bore. Then, reinstall the nut. Do not lock the nut at this time. Flush the injection nozzle. Keep the pump under pressure while simultaneously tightening the adjusting screw until an opening pressure of 3,500 psi plus or minus 50 is obtained. Tighten the nut while maintaining the adjusting screw in its position. Check the opening pressure and readjust if necessary. If proper adjustment cannot be achieved, replacement is necessary. If proper adjustment has been achieved, reinstall the cotter pin. Bend the locking tab up and reinstall the injection nozzle. Maintenance of the injection nozzle is typically performed on a workbench. The injection nozzle requires basic inspection and maintenance to help ensure satisfactory performance. Using a hammer and screwdriver, push the locking tab up. Remove the bolt. Remove the O-ring. Then gently tap out the water ferrule. Remove the second water ferrule and O-ring in a similar manner. Clean the water ferrules after removal. Now, remove the upper O-ring by gently prying it with a screwdriver, then rolling it down the barrel. Remove the second O-ring in a similar manner. For this next procedure, you'll need a hammer as well as a large and small flathead screwdriver. Using the small screwdriver and hammer, gently remove the nozzle tip gasket. Once you've loosened the gasket, use the larger screwdriver to complete the removal. Use a brass wire brush to clean the nozzle tip. Never use a steel wire brush to clean the nozzle tip. To install a new nozzle tip gasket, place the gasket on the tip and use the gasket tip installation tool to hammer the gasket into place. Once in place, check for a smooth, even fit. Install new O-rings on the nozzle body and the water ferrules. Then, reinstall the water ferrules. Be sure to lubricate the O-rings prior to installation. This completes the injection nozzle maintenance. Using a clean cloth rag, clean the cylinder head injection nozzle bore of any debris. Here, as seen in this close-up view of the top of the cylinder head, visually inspect the injection nozzle seat and the cooling water ports. Clean the injection nozzle seat surface using the nozzle seat lapping tool. Place a moderate amount of lapping compound on the tool cutting edges. Place the tool into the nozzle bore of the head, noting that the flat edge of the lapping tool goes to the flat edge of the injection cooling water manifold. After placing the lapping tool into the nozzle bore, rotate the tool with a wrench while applying moderate pressure. Continue until the full contact surface of the nozzle seat has been lapped. Ensure the nozzle bore is re-cleaned after lapping. And again, inspect the seat surface. If nozzle seat defects cannot be corrected by lapping, the cylinder head shall be replaced. When the injection nozzle maintenance has been completed, reinstall the nozzle. With the injection nozzle puller attached, install the nozzle into the cylinder head. Remove the puller and install the injection nozzle hold-down nuts. Tighten the nuts alternately to evenly draw the injection nozzle down into the cylinder head seat. Do not torque the nuts at this time. Inspect the ends of the conduit for damage. Make sure the surface is clean and free of defects, and that the hexagonal section is not rounded. If defects are found and cannot be repaired, replace the conduit. Next, reinstall the conduit by hand threading it into the injection nozzle body. Tighten further using a standard 19mm wrench. Finally, torque the conduit between 70 and 75 foot-pounds using a 19mm crow's foot attachment. Reconnect the fuel pump by rotating the connector back to the conduit. Snug, but do not tighten the hex nut. Check for proper fit by using a feeler gauge to ensure that the flange is parallel to the pump body. Do this before you begin the torquing sequence. The screws should be torqued in the following sequence. The torquing sequence is repeated 3 times. First to 5 foot-pounds, then 29 foot-pounds, and then to a final torque of 73 foot-pounds. As before, be sure to perform the feeler gauge check before each torquing sequence and after the final torquing sequence. If the pump flange is not parallel to the pump body, the flange must be loosened and the torquing sequence must be repeated. While holding the conduit with a 19mm wrench, tighten the 46mm hex nut to a final torque of 100 to 120 foot-pounds. Tighten the 2 conduit flange screws. Torque the injection nozzle hold-down nuts to a final torque of 95 to 105 foot-pounds. Slide the sleeve over the hex nut and install the injection conduit clip. Fill the engine coolant system and, using the jacket water standby pump to pressurize the system, check for leaks. Before installing the gasket, ensure that the gasket seating area is clean and free from defects. Carefully put the gasket in place. Now, replace the valve cover housing. Ensure the threads are free of paint and dirt. This allows the handle to be loosened, facilitating removal of the inspection cover. Open the inspection cover and inspect the gasket. Inspect the cover for nicks. Take special note of the location of the notch. A pin aligns with the notch to ensure a proper fit. Check that the flange is free of debris. Once inspection is complete, replace the cover and tighten. Remove the injection conduit clip. Using an Allen wrench and a soft-faced hammer, loosen the conduit flange cap screws. Now, tap the sleeve toward the conduit flange in order to expose the hexagonal section of the fuel conduit. Next, you will need a 19 mm open-end wrench and a 46 mm open-end wrench. Hold the conduit steady using the 19 mm open-end wrench, while using the 46 mm open-end wrench to loosen the nut holding the injection pump outlet connector. Remove the nut from the injection pump connector. Removal as well as installation of the 6 upper flange screws should be done in the cross-pattern order indicated here. Note the cross-pattern sequence. Loosen the pump's 6 upper flange screws. Again, make sure to do this in the proper order. Now, rotate the connector assembly in order to allow removal of the pump upper flange. For the purposes of this program, the following is being illustrated on a workbench. Normal maintenance procedures would be performed with the fuel pump on the engine. Remove the 6 flange screws on top of the injection pump cap using the proper torquing sequence. Inspect the injection pump cover for rust and any other defects. Remove the spring. Remove the needle valve and inspect the lapped surfaces. Remove and inspect the delivery valve seat. Check all lapped surfaces for damage and repair or replace parts if damaged. After the inspection and maintenance, reassemble the fuel injection pump. Ensure the delivery valve spring is properly positioned on the posts of the needle valve and the connector assembly.